Okay, in day 4 of our probability unit, we're going to summarize the laws of probability that we learned in days 1 through 3. So first we're going to talk about the addition law of probability. If you have two events, A and B, oops. So here's event A, and here's event B. The probability of A or B happening, or both, A or B or both, it's equal to the probability of A happening plus the probability of B happening. But since we count this overlap area twice, we need to subtract that out. That's the intersection of A and B. That's the probability of both of them happening. So it equals the probability of A plus the probability of B minus the intersection, because we had counted that part twice. Conditional probability is the probability of A happening given that B already happened. And that's going to equal the probability that both things happen divided by the probability that B happens. And if we multiply both sides by the probability of B, then we can get that the probability that A and B happen is equal to the probability of A given B times the probability of B. And then if you just switch the order of the letters, you can also say the probability of B and A happening, oops, that should be an A, is equal to the probability of B given A times the probability of A. If two events are mutually exclusive, that means that one can happen or the other can happen, or neither, but not both. So only one can happen at a time. Or neither. So when two events are mutually exclusive, there's nothing in this overlap area. So the intersection of A and B is 0. So that will simplify your addition law, because the formula now becomes the probability of A plus the probability of B minus 0. So that part we don't write. Probability of A plus the probability of B. If two events are independent events, then the occurrence or non-occurrence of one event does not affect the other. So the probability of A given B will be equal to the probability of A, because it doesn't matter if B happens. The probability of B given A will be equal to the probability of B, because again, it doesn't matter if A happened. And so then you can say that the probability of A and B happening, if you look over here at your corollary, the probability of A given B, well, that's just the probability of A. And that's going to be times the probability of B. Okay, so let's look at an example here. If A and B are mutually exclusive events, then the probability of A or B is just going to be the probability of A plus the probability of B. So we're going to have 1/2 plus 1/3. With common denominator, it's going to equal 5/6. If A and B are independent events, then we need to use our formula, and we need to find the intersection first. So the intersection of A and B is going to be the probability of A times the probability of B, 1/2 times 1/3, which is 1/6. And now I can say that the probability of A or B, or both, is equal to probability of A plus probability of B minus the intersection, probability of A intersect B. So So that will be 1/2 plus 1/3 minus 1/6. And we'll get 4/6, which is 2/3. Okay, looks like I worked through this one already. Let's try that again. Okay, the next one, the probability of event R is 0.4, the probability of event S is 0.3, and the intersection of the two is 0.2. Now remember, if two events are independent, up here we learned that the probability of the intersection would be probability of A times the probability of B, so that's what we're testing. So the probability of R is 0.4, and the probability of S is 0.3. Does that equal the probability of their intersection, 0.2? And you can multiply and find out that they do not equal each other. So that means that they are not independent events. Okay, in example 3 we have event X, which has a probability of 0.5, event Y has a probability of 0.7, and they are independent events. So we need to find the probability that both X and Y occur. So that will be the probability of the intersection of X and Y. And that's just going to be the product of their probabilities. 0.5 times 0.7 is 0.35. The probability of X or Y is going to be the union of X and Y. And that's going to be the probability of X, 0.5, plus the probability of Y, 0.7, minus the intersection, minus 0.35. And that gives you 0.85. The probability of neither X nor Y, that's going to be not the union. So the probability of not the union, remember that little mark there means not. And that's just going to be 1 minus 0.85, which is going to be 0.15. The probability of X but not Y, so that's going to be the probability of the intersection of X and not Y. So the probability of X is 0.5. Since the probability of Y is 0.7, the probability of not Y is 0.3. So 0.5 times 0.3 gives us 0.15. And the probability of X given that Y occurs is going to be the probability of X and Y occurring divided by the probability of Y. So we found the probability of X and Y is 0.35. That was in part A. And the probability of Y is given as 0.7. So the probability of X given Y is 0.5. Okay? So turn the page and you'll find the rest of the information on the next video.